half of 36 to 18,
Mhm.
right?
Yep. So where do we start?
Uh,
Yeah. What's A?
uh, one.
It is not one half. Now that it is. Did you mean that? You were just trolling me? Yeah, it's great. What's B? Nope, just six. All right. It was a little rough start, but we're good. So A is the number attached to x squared, and B is the number attached to x. And then we're going to plug them into our happy little vertex formula, which was, is, and will always be the opposite of B divided by 2 times A. So, Joseph, what's the opposite of our B? Absolutely. And what is 2 times our A? This was the part of yesterday's class where, no, it's not one. It is the part of yesterday's class that I felt like, and until they invent something that allows teachers to like have comprehension detectors, like, can you just imagine if I had a grid in front of me and every time you sat down, like you hooked up, you touched your finger to a sensor or something, and then you were wired into your desk. And every time you didn't understand something, like I would get a notification on my grid. Can you imagine? Oh, I'd get so much more done. To be like, oh, there's 7 kids in the room that have no idea what I'm doing. Um, but in the meantime, I just have to rely on my spidey sense. And I got the feeling yesterday when I went over this part, 2 times A, that was where a lot of the stress and the issues arose from. So the steps here are to take the 2 and put it over 1. And then when we multiply, we kind of do multiplication, I've always said, in a couple of phases. Phase 1 to me is this has nothing to do with math phase. That is a positive number. That is a negative number. And 100% of the time, a positive times a negative is a negative. So I always do that first. And then when I multiply it, I just go across the top. 2 times 1 is 2. 1 times 2 is 2. And 2 over 2 is 1. And that's why 100% confidence, the answer is -1. So we're going to take that. That's just the answer for 2A. That's all that was. And we're going to put that answer now, the -1 in the bottom. And now we can actually cash this in. What is -6 divided by -1? It's +6 all day. So we're going to take that answer and we're going to say now that that's part of the vertex. So we cash that in right away, and we, with confidence, should always write this. I now know that my vertex is at the point 6 blank. And the blank can be filled in by now plugging the 6 back into the original equation. And so I'm going to draw a box around what I'm talking about. The only purple rectangle on the board is what I would like you to look at. And that's the place where I'm going to change that X and that X into feeding slots. So it's going to say -1/2 of open space squared plus 6 times open space minus 16. And then into those open spaces, what do we put? The what? The 6, right? What we worked so hard to find. All that negative b over 2a stuff that we worked so hard on is going to go in now to help us find the other guy. So we use a formula to find the first one, and then we just use what my teachers used to call plug and chug. Back when I was a kid, plug and chug. Plug it in, chug it out. So I'm going to change this blank space into the 6 and this one into the 6. And those 6's, again, are the ones that we found by using our formula, right? So once we make it to here, there's really nothing else now on the board that has any significance to us at the moment other than what's written right here. This is the only thing that matters right now because we've got to grind that out, chug it out, and see what it equals. So in order, we want to make sure we do things in the right order. What is just the answer to the red box thing? That's 36. And what is negative 1/2 times 36? It is half of 36. We just have to be cognizant of the fact that it's a negative times positive. But yeah, I mean, so my brain's order of operations, and this is probably just the teacher in me that thinks this way, but like I wish everybody would first look at that multiplication problem and say, I know the answer is negative. And then, yeah, what's half of 36? 18. So we have negative 18 for the answer to the first part. And then the second portion is this purple egg. And that's a positive times a positive. So it's going to be plus, and what's 6 times 6? And then we copy down the minus 16 at the end. And then we math. And plus and minus are just performed left to right. There's no one that takes precedence over the other. They're just left to right. So we're going to go negative 18 plus 36 is 18, and 18 minus 16 is 2. And that concludes the work portion now, Joe, of the problem, because we now can go up here to where I wrote vertex at 6 blank, and I can add the number 2 for my y coordinate, right? So at that point, what we're going to do is we're going to go to the graph and we're going to go plot the point 6, 2, which is right 6, zoop, up 2. So I'm going to make my first dot right there. Got it? Okay. Now, from there, there's all sorts of graphs that could be made. I might have a graph that goes up like this. I might have a graph that goes up like this. I might have a graph that goes down like this. It might go down like this. But see, all of those options, it's not a guessing game. I don't get just to pick one. All that the answer to what's it going to look like is going to be determined by the number in the big chonker red box. Nothing else matters at this point. All of the other numbers that you see on the board are meaningless, useless, because that number tells me two things. What's one of the things he tells me? It is. So all those ones I drew that go up are out. We know that the graph opens like the St. Louis Arch now, right? Downwards. And what other thing about it is important? What does the half do?
Well, I know what it does. Yeah. Word of mouth.
There's probably about 6 other people who are eavesdropping and paying attention to our conversation. So I'm going to try to put words in your mouth and explain what the half does for the sake of people that are part of this conversation. Right? You ready? So what we have to be aware of is what normal behavior for a parabola is. I can't stress enough how important it is that you just know what would a normal graph do. No, I think I wrote this a couple times yesterday. So under normal circumstances, when I leave the vertex of my parabola, I would go out 1 and I would go down 1 because 1 squared is 1. And again, under normal circumstances, I would go out 2 and I would go down 2 squared, which is 4. Just turn around, Roddy. Under normal circumstances, I would go out 3 and I would go down 9. Under normal circumstances, I'd go out 4 and I'd go down 16. If I went out 5, how far down would I go? Correct. And that takes about 10 or 15 seconds to write. And I think it's worth the effort, at least for me as a teacher, because now I can explain to you what I came here to explain. What the half does is it takes all these numbers in this red box and it multiplies them by a half. In other words, in simpler English, it just divides them all by 2. So what is 1 if you take half of it or divide it by 2? It's a half. What's 4 if you divide it by 2? 2. What's 9 if you divide it by 2? 4.5. What's 16 if you divide it by 2? 8. What's 25 if you divide it by 2? 12 with a half left over. And we could keep going like this, but that's what the half does, is it takes all of your verticals, not your outs. Your outs are always out 1, out 2, out 3, out 4. That never changes. What changes is the amounts that you go up and down get modified, multiplied by the number that's in front of x squared. So when we go back to the graph, the conversation we have to have is, it can come at you in two parts. It can be like, what would I normally do? Or we can skip that step. So let's say I go out 1. How far down will I go? A half, right? Because we already wrote that down. At least I did. And then if I go out 2, how far down will I go? 2. And you'll notice on this east side of the graph, I'm out of real estate. That doesn't mean I should stop, because I've got all this real estate over here in the big red circle. I'm not going to throw that away just because I ran out of space to the east, right? I'm going to keep on chugging on. I just can't plot any more points to the east, but that's okay. So now let's go back to our vertex and let's go out 1, 2, 3. Can you see my pen moving up here? 1, 2, 3. How far down will I go? 4.5, because that's half of what I normally would do. So I'm going to go down 1, 2, 3, 4.5. And I think I can probably go again. Probably room for one more, I'm guessing. If I go out 4, how far down will I go?
8.
8. Half of what I'd normally go. Normally, I'd say 4/16. Go out 4, go down 16. Take half of 16, you get 8. So I'm going to go out 1, 2, 3, 4, and then go down 1, 2, 3, 4, 5, 6, 7, 8. And you can see we're pretty much pressed, I think, to the bottom here. I can't imagine we're going to have any room to plot anymore on this particular grid. So off to the right, you would sketch it just with what you've been provided. And then to the left, you've provided yourself with more opportunities to connect points like such. So sometimes you get graphs that are a little heavier on one side than the other. And that's just if the vertex pushes itself to one side, then that's just, the name of the game, right?
Yeah.
Does that make sense? Okay. Mm-hmm. Mm-hmm. Anyone have any questions? Those of you that were listening in on question 2? It's just it's a process you got to go through. There's a lot of math to do. Finding the vertex is pretty math heavy. What do we do first?
Find our name,
What's A?
30.
What's B?
I don't know, maybe 0.
We wouldn't be having this conversation if the equation said y equals 3x squared plus 0x minus 5. And so just bear in mind that is technically, would you like a copy of this? That's fine. I'm just asking. Just if you decide you do, let me know. So we've seen this before with quadratics. They can have terms that are missing, right? If it's got an x squared term, it's called a quadratic. It could be missing b, it could be missing c, it could be missing both b and c. It's still a quadratic. But it's there. It's a 0. You just can't see it. So having said that, we're going to use our happy little vertex formula, which, again, for the 94th straight time, is still the opposite of b divided by 2a. What's the opposite of b? And what's 2 times a? 6. And what's 0 divided by 6? 0. Yeah, 0 divided by anything is just 0. So what we can now state is that the vertex of the graph is at the point 0, idk. And as always, to complete the puzzle or to answer the question of what's the y coordinate, plug it back in. You'll notice if you were to go back and listen to every explanation of this that I've given you, I have yet to veer off course. It's very repetitive. what you do. You find A, you find B, you plug them into the happy little vertex formula, you get an answer, and then we're going to plug that back in, and we're going to, like, it's rinse and repeat, right? So much of math is just rinse and repeat, mastering a process. So inside the purple rectangle is a math problem, what we call an expression. So I'm going to write it down, except wherever it says X, I'm going to change it into an awkward void like this. And into the void, what am I going to put?
0.
0. And then I'm going to order of operations this little sucker. And I know, and you know, that 0 squared is 0. And 3 times 0 is 0. And of course, 0 minus 5 is negative 5. So we now have a vertex at negative 5. I knew this problem would be one that you'd have questions on, and I appreciate that you'd ask it. So the moral of the story with this problem is things sometimes are going to look a little bit different. Just have faith in the process. Find A, find B, plug them in, plug that back in. And then from here, I'm going to go to my vertex, of course, which is at stay put down 5. That's what the point 0, negative 5 means. Is it's telling you to not go right, not go left, don't go anywhere, just go down. So I'm going to go down 5 and put my vertex right there. The only thing left on the board now that matters is the number in the red chonker box. That's it. Get to this point, the only thing that matters is what's attached to X squared. That's what I call the builder. Everything else has just been trying to find the directions to the build site. Vertex is the build site. And now that I'm there, I need that number 3 to tell me what to do. So what he says, since he's the number 3, is if you go out 1, you would normally go up 1. He says, multiply that by 3. He says, if you go out 1, I get it, or excuse me, out 2, I get it. You normally go up 4. He says, multiply that by 3, go up 12, and so on and so forth. So all of your verticals are being adjusted by the number in the red chonker box. So I think we're only going to have room for the 2 points, and you probably don't need me to point this out, but just in case, if we were to go out 3, we normally go up 9. But because there's a 3 in the chonker box, what's 9 times 3? We clearly don't have room to go up 27 jumps. We'd have to rescale our axes, and we don't want to deal with that. So we're going to just take whatever real estate was given to us, use it to the best of our ability. So all I have to work with is out 1, up 3, triple the normal. And this one I'm going to need a little bit more space. If I go out 2, I go up 12, triple the normal 4. So I'm going to go up, yeah, it's literally all the way, well, almost all the way up. Yeah. So we're going to head all the way up to right here. That's a distance of 12. That's it. And again, I tried to kind of tell you this the other day. The computer makes these, and it's programmed to give you enough room for at least a couple points, right? So I don't think you're going to find any, maybe I'm wrong. If I'm lying to you, it's on accident, but I don't know that I've seen anywhere where the computer sticks the vertex like up here in this corner and then expects you to make a parabola. Like, I just don't see that coming. The computer is going to give you a vertex that will then allow you a little bit of workspace. But if you find one that's contrary to that, then apologies for the inadvertent lie. Is that making sense? Find A, find B. Plug them into the happy little vertex formula. Plug that back in. Over and over again.
Are you pulling up number 5 and 6?
Let's pick one. Sure. Five is, without question, I almost took it off this assignment, but I didn't. I had my finger on the space bar. When I'm making these, the computer, if I highlight a question and hit spacebar, it generates a new question. And I was hovering on the spacebar on problem 5. And I thought, no, that's good for us to try a nice challenge like this. And so 5 is far and away the worst of them all. 6 looks bad, but it's not. So 5's pretty special in the poo-poo category. But what doesn't change is the process. It's just going to be a little bit more of a miserable process. So we're going to start with A. What's A? What's B? Mhm. So we're going to start with that. And until the end of time, the x-coordinate of the vertex can always be found by using a formula, negative b divided by 2a. So this is going to involve some work. And I would really encourage, for those of you who are kind of watching along and just writing it down, I'd encourage you to be enough of a part of this process that you could raise your hand or interrupt me and say something like, I don't know how you did that, because this could get a little bit ugly, okay? So when we calculate negative b divided by 2a, what it's going to look like is this. The negative b is going to be 10/3. And then that's going to be over 2 times a, which is 2 times negative 1/3. Zero chance that that's confusing right there. That's just negative b over 2a. I haven't done any math yet. But what kind of is bad about this is that now we have a little bit of a math dilemma inside of a math dilemma. So it's like a problem inside of a problem. And so we have to do this bottom problem next. And every single one of you in this room, as of yesterday, would be responsible and accountable for knowing that when I multiply those together, there's a process to it. And it is to take the whole number 2 and put it over 1, and then multiply it by the negative 1/3. Fractions like to multiply by other fractions. And then I'm going to go and I'm going to use my common sense, and I'm going to say that's a positive, that's a negative. So I know my answer is going to be negative. And then I'm just going to go straight across the top and the bottom. 2 times 1 is 2. 1 times 3 is 3. So the answer to the bottom is negative 2/3. But again, that's just the bottom, right? Okay. So what I'm going to do now is I'm going to erase this bottom. And in its stead, I'm going to bring in the answer to, like, what is it actually? Do you see that? You with me? Okay. What's the trick that we use? Because this, of course, is just one big division problem, right? It's what fractions are. Fractions are division. Newsflash, right? How do you divide a fraction by another fraction? Keep, change, flip, copy, dot. Sorry, hang on a second. So the keep, change, by the way, I should just ask right now, does anyone have any stress before where we are right now? Okay. So once we get here, keep, change, flip, copy, dot, flop. Say it however you'd like to. What happens is we get 10/3, and then we change it to multiplication. We still keep the second number negative, but then we flip it over to 3/2. So that's how you divide fractions. Right? And then you can reduce early, you can reduce late. It kind of doesn't matter when you reduce. I know where I'm at on it. Like I would cancel some things out right now, but I know that also causes some people some stress. So here it goes. Common sense. That's a positive. That's a negative. So now I know my answer is a negative. And then I just go 10 times 3 is 30. 3 times 2 is 6. And we all know that 30 divided by 6 is 5. Therefore, finally, we know the answer is negative 5. And what that means is we can now write this down. We can say we know. Say again.
That's on question 5.
Oh, thank you. So we can now say that the vertex has an x-coordinate of negative 5. And that's just part of the battle. I'd say it's probably the worst part, but we can all write down, here we go. Vertex is at negative 5, comma, blank. some serious heavy lifting on this problem, right? Any questions? Okay. So once we survive that, what do we do next? I would just say if you really don't know the answer to this question, then
You put -5.
yeah, I mean, I know it's kind of like a teenager thing and you're like waiting for someone else to answer. I'm just saying out loud that if you really don't know what to do next, then I have wasted a lot of your time in the last couple days. So yes, thank you, Rowdy. We have to take that answer and put it back up into the math problem right here. Thank you for that. And this isn't going to be pleasant at all, you know? So there's no sense in belly aching about it. It's even a guy like me don't get any joy out of stuff like this. It's just a grind. So it's going to look like this. It's going to say -1/3 of blank squared minus 10 thirds of blank minus 13 thirds. Nightmare of a problem. And what's going to go into those blanks? -5. What we worked so hard to find. So we're going to put it the -5. This one, we're going to put it here. And we're going to put it here. And so the only thing that matters now is the math problem that you see at the top of the board. That's it. That's our focus. And we have faith, right? Just stay the course. Of all the things you see in red and purple up there, what's the one thing that has to go first? The exponent. You should have complete and total isolated vision right now and be looking at nothing other than what's in the green squiggle box. Nothing else. What is the answer to the green squiggle box? It is +25. And I'm not the cool kid that's going to like try to show everyone how fast I can go. I'm just going to take my time. It's -1/3 now times 25 minus 10 thirds times -5 minus 13 thirds. And some people just plug everything into calculators. Throughout the years, they've mastered the art of the fraction button. So what I'm doing right now, I'm not necessarily talking to those people because I know that they're just going to go boom, 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 and their calculator is going to give them an answer. I'm a believer in that we should all be the expression I use is we should all be mathematically literate. I will die on that hill, right? There's always the old, I don't use the whole cliche, what would you do if you didn't have a calculator? I just think there's some pride in us being able to know I could do it if I didn't have one. Take that, math gods. So I'm a big believer in mathematical literacy. So we should be doing the grind here. So what I see, the stress that I see is that there's a math problem inside of the red box and there's a math problem inside of the purple box. And I know for a fact that every one of you in this room can do this, but we need to attack them individually. So what's the trick to the red box? What's the trick to any multiplication problem? Hallelujah. So I'm going to take the whole number and I'm going to put it over 1. And I'm going to rewrite this as -1/3 times 25 over 1. And then I would assume the answer, if I asked you for the purple box, you'd say the same thing. So it's going to be -10 thirds times -5 over 1. Loves me some basic skills. Did I didn't do that. What are you talking about? That?
Yeah.
Oh no, that's clearly a 3. Wait, is that what you're talking about? I'm sorry. I was going to say you can't prove it, but I'm recording, so never mind. The proof shall live on. Thank you for pointing that out. So at this point, it's ready to go. All the hard part is over. Now we just have to understand, like when we multiply fractions, what is the answer to the red egg? -25 thirds, right? That's just top, bottom, bottom. What's the answer to the green egg? +50 thirds. And of course, the purple just remains unchanged. And the nice thing, if there's anything this problem has to offer after 8 minutes of absolute mathematical misery, it's that at the end, I've got a math problem where the bottoms are already all the same. Thank you, math gods, for that. So at least I got that going for me. What we know about this green, red, purple problem is that the answer is gonna have a 3 on the bottom, right? And then the trick is just to kind of embrace the purple caterpillar here and just add all the numbers together. Basic math. What's negative 25 plus 50?
45,
What's 25 minus 13?
12,
And what's 12 thirds?
4.
After all of that, we know the vertex. And so the vertex can be found. We already knew that the vertex was at negative 5 something. We now know that the number to go with the negative 5 is the number we just worked our butts off to find, and that is 4. Still good?
Yeah.
You didn't enjoy that?
No, so when I was doing that problem, the only thing that like I didn't get right was the fact I didn't divide the 12 and the 3.
You left it as 12 thirds?
So just I was really thinking about it.
Listen, I'm not gonna like throw shade because you watched me just write a 5 when I should have written a 3, but I'm gonna make fun of you a little bit and say, hey, you should not do that kind of stuff. It happens. I see it all the time. Kids leave like 10 over 2, and then I write something snarky on their quiz like, dot, 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 you mean 5? It happens. So we get so wrapped up in all the hard math, we forget to look for the easy stuff. So anyhow, we finally know a gall darn vertex, and it's at left 5 up 4. So I'm going to go there. I'm going to go left 5, and I'm going to go up 4. Zoop, and I'm going to put my dot. We're still not out of the woods. I'm going to erase, since I'm recording, I can do this kind of stuff. I'm going to erase every single ounce of writing that I have within eyeshot of this. Because what I really want to point out to you is that there's only one thing now on the board that matters. What is it?
Negative 1.
That's it. Clearly, you got that memo. Good job. The only thing on the board now that matters is the number in the red chonker box. And if you haven't gotten that memo, then I failed you. Nothing else now matters. So we need to make a little list over here. Let's make a to-do list. Normally, if I was going to make a graph, I would go out 1 and I would go down 1. Normally, if I went out 2, I would go down 4. Normally, if I went out 3, I would go down 9. And again, normally if I go out 4, down 16, out 5, down 25, out 6, down 36, out 7, down 49. What am I going to do with all the numbers on the far right?
30.
I'm going to take a third of them. And for people that don't like fractions, AKA, i.e., 96% of the people in this room, what's another way to say a third of something? It's divided by 3, right? So let's head to these numbers over here on the far right-hand column, and let's just divide them all by 3. And I'm going to cross them out as we go. What's 1 divided by 3?
1/3.
1/3. What's 4 divided by 3? It's 4 thirds, which equals 1 with 1/3 left over. If you can't answer a division problem, I've been telling you this since August, just leave it as a fraction. You ask people, what's 10 divided by 3? And they go, I don't know. It's like, well, the answer is 10 thirds, man. What's 9 divided by 3?
3.
What's 16 divided by 3?
16.
16 thirds, which means 3 goes into 16 5 times with 1/3 left over. What's 25 divided by 3? That's right. It's 25 thirds. How many times does 3 go into 25? 8 with 1/3 left over. What's 36 divided by 3? 12. And I think we're probably out. I don't think we're going to have enough room for 49. It would be 16 and a third, just for the record. But I'm guessing we don't have enough room for that. So let's do it. I'm assuming that you wrote these numbers down and that you didn't just watch your teacher do it. So all these numbers on the right are going to be the amounts that we drop. So let's do it. Out 1, down how far? Third. So just make it look like you're going less than halfway. Out 2, down how far? 1 and 1/3. Out 3, down how far?
3.
3. And you can see this is another one of those instances when I'm out of room on the west, But that doesn't mean I'm not gonna like quit. I'm just gonna keep working in the other direction. But on this side, I can sort of, you know, quit, I guess. If I go right, oh, I didn't do this one over here. Silly. If I go right 4, how far down do I go? I already wrote these down once. I'm not doing it again. So
5.
5 and a third. So 1, 2, 3, 4, and then down 1, 2, 3, 4, 5 and a third. And I think we have room for one more. If we go out 1, 2, 3, 4, 5, how far down do we go?
8.
8 and a third, which is 1, 2, 3, 4, 5, 6, 7, 8 and a third. And I just feel like we're probably going to run ourselves out of space on the next one. So then I would just connect it like this. Ooh,
Gave the last one.
can I do one more?
Yeah.
That's out 6, down 12. Oh, you're not wrong about that, are you? Out 6, down 12. Good call. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you can see I missed it a little bit. So I probably have to modify my graph. So that's a gnarly math problem. And it's interesting because some of the problems on this page, they take like 3 minutes. That one easily 10, 15. I don't know. But it's a whopper. You won't struggle as much on problem 6, just because there's going to be less fraction stuff going on. You want to try it?
I just need like
The beginning?
Yeah.
Sure.
and then like kind of like the start of the problem.
No problem. It's going to be the same explanation. So you know that it's going to be A equals whatever, and it's going to be B equals whatever. And then we're going to do what we always do. We're going to plug it into the opposite of B divided by double A. What's the opposite of B? And then the double A is a math problem. I'm going to change colors and just write it in red so we can all understand that sometimes double A is easy. It's like third grade, like 2 times 1. Oh, 2. But in this case, it's not like that. I've got to do an actual math problem to answer just the bottom of the fraction, and that's going to be 2 times A. Correct. And again, what's hard, not hard, it's just challenging as a teacher that in a room with 20 kids, you'll have 5 kids that just know it's negative a half. You'll have 10 kids that can kind of figure it out, and you'll have 5 kids that are like, I have no idea. So trying to cater to all of those levels is the challenge. So I'm sorry if you feel like, why are you going slow? I just have to do this. What's the trick to the red math problem on the bottom? Putting the 2 over 1. So I'm going to start by taking the 2 and writing it as 2 over 1. And then math it. What's 2 times 1? 2. What's 1 times 4? 4. Slap a negative on it. What is the overall answer? I know Rowdy already said it. Negative 1 over 2. It's negative 1/2. If it is bottom heavy, it will stay bottom heavy. Things can't change like that. But again, god damn, that's just the bottom. Keep change flip, copy dot flop. So it's negative 3 over 1 times negative 2 over 1, which equals
6. Yeah, 6.
it's a lot of work. Nowhere near as much work as the last one. So we can all write proudly that the vertex of this parabola will be at a point whose x-coordinate is 6. Hallelujah. What do we do with the 6? Plug it in. Same as every other time. 100% of the time. The answer will never change. You go back up here to the OG math problem, and everywhere you see the letter X, you just change it into what you worked so hard to figure out that it was. Okay, so we're going to write negative 1/4 of blank squared plus 3 blank minus 7. What's going in the blanks?
6.
The number we worked so hard to find, 6. Order of operations kicks in. What's 6 squared? What's negative a quarter of 36? It's negative 9. What's 3 times 6?
Uh, 18.
18. Negative 9 plus 18. 9 minus 7.
Yeah.
Done. Just like that, we know the vertex. And we'd have the same conversation again. Of course, we would go to the vertex first. We would go right 6 and up 2. And then we talk about the graph. And of all the things that are here on the board, what's the only thing left that matters? The negative 1/4. Somehow you sat through this and still don't hear me say that, then again, I am just wasting your time. That number is the builder. It determines now why do I make this thing? I figured out where to go. I just don't know what to do. So again, you're just going to take all of your normals. Your normal downs are 1, 4, 9, 16, 25, 36, 49, etc. Right? You're going to take all those and you're going to divide them by 4. 1 divided by 4, fourth. 4 divided by 4, 1. 9 divided by 4, 2 1/4. 16 divided by 4, 4. 25 divided by 4, 6 1/4. 36 divided by 4, 9. 49 divided by 4, 12 1/4. So on and so forth. And those are going to be the amounts that you go down. So I'll leave that to you. Okay.
You know, in high school was math like strong suit.
Yeah.
Really? What subject was it?
Um,